We've looked at non-polar R groups, so obviously we're about to get to the polar R groups. And before we do, let's have a look at some of the different ways that the general amino acid structure is shown. Sometimes you get it like this, and that's pretty well exactly like I've got it here. C, double bond oxygen, OH, and a nitrogen with two H's on here. And I've got an H up here, and then I've got my R group down here. On this side, it looks different because this is how it is in water, and you'll notice they've put things in slightly different places. So you might have to look quite closely at a diagram to recognize it as an amino acid. So there's the carboxyl group. It's given away its H+, so it's negative. It's done the acidic thing. And this one, NH2, but it's gained an H+ ion, and now it's NH3+. So that's acted as a base. So it's neutral, but acid and base at the same time. And let's have a look at this one. It's serine. So if I've got serine, here's my R group. So it's got the carbon, like everything has, and it's got an OH group there, a hydroxyl group. And you know about hydroxyl groups because they're in water. You know that that hydroxyl group is going to have a delta positive on the hydrogen and a delta negative on the oxygen. And that, as a result, is going to be hydrophilic. It's going to attract water. So if we've got this little molecule on, oh, I've missed out something. If we've got this little molecule on a, there we go, on a protein, then this part of it's going to be hydrophilic. So when it makes its shape, this bit is going to attract water, and it will go to the outside of the molecule where there is water, as opposed to the hydrophobic R groups with no polar stuff on it that are going to be repelled by the water and go to the inside of the protein. And all of these interactions with the R groups are what gives the protein its shape. And the protein shape is everything. The shape of the protein determines what molecules will fit into it and which molecules it will fit onto. And that means how it acts as an enzyme, how it can act in a muscle, how it can act in order to, I don't know, do any of the millions of things that proteins do. So let's go on. Asparagine and serine are polar. I didn't make the asparagine because I think I've made quite enough amino acids. Here we've got the H2N, and we know what that does. We know it's a polar bond. We know the H is a delta positive. We know the N is a delta negative. So we know it's going to be hydrophilic, which of course the polar R groups are. So now we'll move to something else that's a bit more than a polar R group. And so I've got, what have I got here? I've got no idea. I've got the wrong one. Here we go. So I've got this one now. I've got a CH2 here and a C double bond and an OH there. And if I attach that to my base model of an amino acid, here it is. And what I've got now is a mess. What I've got now is an acidic R group. And the reason it's an acidic R group, it's got an OH sticking out there. And you know what an OH group does in water. It does that and gives away the H+. Actually, it's not so much just the OH group, it's the COOH group. And that will act as an acid. That means that will be a negative charge. If that's a negative charge, this is a negative ion. And if it's a negative ion, if a positive ion comes along, it can form an ionic bond with that positive ion. And that's another thing that can hold different bits of the protein together to make its final crucial shape. So here we've got, yes, the COOH, the H is missing, and here another acidic R group, glutamic acid, COOH, there as well. And obviously if you've got acidic groups, we've got basic groups also. And let's have a look at this. This is a complete mess. This is an acidic, this is a basic group. And you can tell it's a basic group because it's got an amino group there. And you've already seen what an amino group does in water. It attracts another H plus to there because of the polar nature of that. If you've got a base here, then that's going to attract the H plus, and if it attracts the H plus, that means this is going to be a positive ion. If it's a positive ion, it can attract a negative ion. So if somewhere in a protein structure you've got a basic R group, forms a positive ion, and that can attach to another place where there's an acidic R group, because that makes a negative ion. I think that's quite enough for now.